Yes. So we will have it in two places. Let's see if we have a good discussion. Because the problem I see is that because the people is not discussing this topic, they don't know which direction to take, right? And having multiple monitoring solutions, I don't think it's good. It will be too complex. You think so? It will be necessary? No. But that means that iPhone or Android will have multiple of them. They will not love it. Yeah. Yeah. We'll see. I will always forget to scan it. Is it with an RFID? You come into the room, you are automatically checking. We've got a very full agenda today, so let's get started. Welcome to the happy meeting at IETF 126. There was a QR code up here until it was replaced by this thing. So if you haven't joined in Meet Echo yet, there's a link from the agenda. There's a QR code at the back of the room. There's QR codes usually stuck to the microphones. So please make sure that you hop in and join the Meet Echo. And this session is being recorded as usual. When you're in Meet Echo, you can join the queue with the hand button, same as it's been for the last couple of meetings. If you're in person, you still need to join the queue, and then you should line up at the mic line, and we'll call on folks in the order that they join that queue. This is the note well. These are the terms under which we participate in the IETF. Please make sure that you've read it. This is Monday, so you haven't read it that many times this week yet. So please make sure that you've read it. Take special note of the responsibilities that are placed upon you in regards to IPR, and also a brief reminder that we operate with a code of conduct. So if you observe any violations of that code of conduct, you can reach out to the chairs, the ADs, the ombuds team, and they'll assist you with that.
Thanks, Andre.
We got some helpful links for the PDF. And this is our very full agenda for today. So we've got a bunch of stuff to talk about. We're going to talk about the main document. We've got implementation updates from 3 major browsers. And then we've got some conversations about web tester stuff and then some error reporting. So with that, let's get started with our first talk.
Or do we need a note?
Good point. Would anybody like to volunteer to take notes? In this AI-assisted age, it is less of a burden than it used to be.
Do we have AI tools?
There are some unofficial ones that are taking the recording of the session and the transcript and stuff. So it really is legitimately just major decisions now, as opposed to like try to actually scribe everything. I see a hand from Brian. Thank you, Brian. Okay. And then we should have a clicker.
The pink cross.
Let's control. Does this work?
That's a good question. Well, maybe it needs to be.
It needs to be
down
plugged
there.
into the. All right, you can just say next slide. That works too. It should be plugged into one of these. All right, we'll mess with that. All right.
Okay, hi everyone, I'm Nidhi, and we'll be talking about Happy Eyeballs v3. Next slide. So we'll start with some of the updates for the latest version of the draft, and then we'll go through some of the open issues. Next slide. So here's an overview of the changes that we've made to the latest version of the draft since the last meeting. You'll notice some of the PRs were just editorial. We changed mentions of address to endpoint where it was appropriate in the draft to be more consistent with language. And then the second one was replacing the word interface with PVD since it's more accurate. Next slide. This was an issue that was raised earlier as well. We had previously added some text where we said these issues might be specific to IPv6 traffic, but it still wasn't quite clear. So we've now added some more text to say that this is due to the IPv6 header that can be larger than the IPv4 header. Next slide. And then we've also added a lot of examples for the DNS answer processing as well of what are the different situations that might happen of what answers we get and then how do we react to that in the algorithm. So one example is if we get the HBS and Quad A record, we can start the IPv6 attempt right away. And then when we get the A response, we can start interleaving the IPv4 and IPv6 addresses and then continue on with the race. And then the second example is if we get HBS and A, but don't get the Quad A, we start the resolution delay timer. And then when we get the Quad A after 10 milliseconds, we'll start the race with both IPv6 and IPv4. Next slide. Yeah, I think that's the major updates. Tommy, do you want to talk?
Ben, is that a now question or a later question?
Hi, I just saw something go by that the concerns about IPv6 are due to increased IPv6 header size. That doesn't sound accurate to me. I really would have expected that the answer is due to different fragmentation handling. Maybe somebody who is familiar with fragmentation issues should take a close look at that and make sure that we're describing that situation correctly.
Sounds good. I think we'd had a long hallway conversation at one point with Corey about some of this, but we can circle back and make sure that loop gets closed.
Okay, sounds good. All right, I'll talk through some of the open pull requests here. So if we can go to the next slide, or do I have a clicker?
This is not working, but if you have your phone, you can click with that.
Sure.
Up to you.
Request.
You have to request them fully, or hang on, I can just transfer to you.
Okay, so the major thing that we've been discussing for a while now is updating the IPv6 only network handling guidance. This is an area of text that we had a lot of original guidance around in Happy Eyeballs v2. That was in an age before we had the pref64 option, and all we had was like, oh, this new DNS64, NAT64 thing. We had done some updates, but we had realized like the guidance was not fully complete. So last meeting at IETF 125, we had a call with a number of people, and we discussed briefly in the working group session as well what the proposal would be. I've taken a stab at turning that into text, and so this is PR number 137 on the doc. So a lot of this is please review and help get this merged in so we can finally resolve a whole slew of open issues around v6 only network handling. So that's what we're trying to do. So just to briefly summarize the changes that I'm making in this PR. So first, there is a set of changes that's not down in what used to be the section around IPv6 only networks, but is up at the beginning for the rules for sending queries. And so this is section 4.1. This is kind of like the first stage of Happy Eyeballs of like, what do you even send? And so it's simplifying things to say that, okay, overall, if you're deciding between A, quad A, sending, it's about the routes that you have within your PVD. Your PVD is the provisioning domain. So it's the set of coherent network information for the interface, DNS resolver, et cetera, that you have. So if you have global v4 connectivity, you send an A query. If you have global v6 connectivity, you send a quad A query. And then also, if you are aware of a NAT64 prefix in any way that you're aware of it, you must also send an A query. And so this is different than what Happy Eyeballs v2 had, but this is what we've been talking about for a while in here. So then there's the lower section that goes into detail about so this previously was called like the IPv6 only and IPv6 mostly networks. And I've renamed it to just be about how to handle NAT64, because that's really all it comes down to. And here you essentially can discover, are you on a network that has a NAT64 prefix that has pref64? You can either discover that from the RA option, or you can discover it by doing the query for IPv4 only.arpa. And all of the rest of the logic comes if you do find that prefix. So if you cannot discover that, then you ignore everything else. You just kind of carry on as if you have true v6 only or normal dual stack. So if you do find the prefix, you must send the A query, as I mentioned before. And if you ever have IPv4 literals that were added, like that you're trying to directly connect to, or that you learn about through IPv4 hints in the SVCP records, etc., you synthesize those. And you must treat the synthesized addresses, including anything you get back from DNS64 that you realize has been synthesized, as a v4 address for the purpose of the Happy Eyeballs sorting and grouping and everything else. So you rank it as if it is a v4 address because it's not native v6 all the way, but this is all you need to do for this basic case. So that's what the PR currently does. It also, as we noted in some of the discussion, it eliminates one of the configurable values that we used to have overall, which was this last resort local synthesis delay, which is a mouthful. And so we can get rid of it. That's great. So this was a timer that used to be around to say, should I send an A query on this v6 only network because maybe something's busted otherwise. We don't need that because now we're always going to send the A query. So great. The other thing that I think based on the discussion we are having on the PR that we need to do is address the split tunnel VPN case. This is something that did have text in there before. I had deleted it as part of this PR because I think a lot of that was outdated, but I think we do need to bring back something there. This is a case where potentially you have received a DNS answer that maybe a synthesized v6 address from a v4 address, and that v4 address really belongs to a split tunnel VPN configuration where you would natively use v4. So I think we need some text around that. I'm happy to hear suggestions on ways that you think that could be phrased. But I believe other than that, this captures what we had discussed last meeting. So happy to hear comments. Eric.
On the VPN tunnel topic, I was just doing a full read through of it earlier today. And one thing that did jump out to me is I think the kind of section, the topics around PVDs and VPNs probably want to, and network connectivity probably want to get pulled up to a top level section, because I think there's a number of these things that get interwoven throughout on things like when you need to flush your DNS cache on network changes. and kind of pulling that up out of this section to a top level thing would probably make more sense and make it more readable.
Got it. Thank you. That's a good idea. Jen.
Yeah, Jen Linkova. So I think I might create some confusion in the PR, particularly because I'm looking at the slides from the last meeting, and I think on those slides in section of what we're going to do with quad A answer is not exactly what on your slides right now and not on the PR. So we might need to maybe sit down and rethink it again, because I think the idea, and even my example, which was on the slides last time, right, gives you different results. So like, I think that we did discuss unsynthesizing, at least last time, right? So maybe what you're proposing is a better way, right? I'm just thinking about, we need to talk about, how to solve VPN case with that approach, right? Because another suggestion, I actually like Lorenzo's suggestion from one of the previous meetings, that maybe we don't need to think about all of it and just let default address selection to deal with that.
Right. So I guess I would be curious, and maybe if you can do it now, or if you can do it on the PR, to unpack like what are the meaningful differences, because I think I acknowledge that what we had previously from the notes for the side meeting is slightly different, but as I tried to turn those into the actual guidance, that's how we got to the PR. So I think specifically for the unsynthesizing bit, there's the bit about treating the synthesized addresses as v4 addresses. So you could say that anytime you have a synthesized v6 address that you get from DNS64 or whatever else, you first desynthesize it into v4, you run it through everything as v4, and then at the last minute before you actually use it to connect to anything on this PVD, you resynthesize it back into v6. I think that's morally equivalent to just saying, I have it as a v6 address. I know what the inner v4 is, and I treat it like v4, but I don't actually have to literally in the code unsynthesize it and then resynthesize it. That's more of an implementation detail to achieve the end,
Okay.
I think.
Yes, I think the idea was that if you have synthesized v6 and you have v4, we want to make sure the traffic will be sent as v4. So if you have CLAT or if you have more specific routes for that v4, right, it will be treated as v4, not for the purpose of sorting, but for the purpose of sending traffic. And that would solve VPN case, right? But I guess, we'll need to talk about it a bit more, maybe in the PR.
Okay.
Philip Teasel. I already commented on the PR that I think the VPN case will more or less be the same issue or the same discussion as a PVD. So I would just say a VPN is nothing like an implicit PVD that defined itself by the VPN configuration. But I think if we think about the cases, what could go wrong? So you could use DNS sensors from a wrong resolver that's solved by treating as a different PVD. If we now have an IP v4 address, we only could resolve through that VPN. We already have resolved it through the PVD and would use it in the context of the PVD and would use the root of that PVD. So in the end, I would argue that if we get PVDs right, we also cover all the stuff for VPN.
So I think that aligns well with what Eric Nygren was saying for kind of pull it up into a broader section there. So one of the questions I would have here, because I think where it can get a bit messy, is that if you come from a purist PVD standpoint, you would say I don't ever use answers from one PVD on a different PVD, right? But I am aware of split tunnel VPN cases where you the deployment expects things to resolve in one place, but then end up connecting over a different route.
Oh, okay.
Just because that's how implementations have worked, and there are things that do depend on that. So I think being strict around that would cause breakages. That's my concern.
I agree on that, but I think perhaps we have to think about, we have leaky routes and other concepts, so we might think about leaky PVDs that say if you end up that DNS resolution leaking out of that PVD, that's fine. By definition, to care about things like split tunnels. So you do DNS, it's marked as a leaky PVD, and say, okay, this DNS answer I'll then use on the default PVD or default route or whatever gets me out of that PVD.
Lorenzo.
Lorenzo Clitti. I think the problem is with when we define PVDs, we didn't add any mechanism to declare the absence of information in a PVD. Like the PVD can say these things are part of the PVD, but there's no way to say this is not part of the PVD. And there's also like no easy way to like fault in parts of like the routing space that are coming from another PVD, right? I think that the spec really doesn't say that. And so the thing with split tunnels is that like you basically sort of the VPN has to abdicate most of its space and it has to come from somewhere else. It's like actually very difficult to use PVD to represent that. So I think that's a bit of a challenge here. I do wonder whether we should fix the PVD stuff, but you know that certainly doesn't belong here.
I guess, would you argue then that we should, kind of like what it did before, just talk about, hey, split tunnel VPNs are a thing separate from trying to reconcile the whole PVD world? Or
well, I mean, I think in this talk, I think giving pragmatic guidance is probably the right approach, right? And yeah, even if it doesn't match perfectly with the stuff we introduced in PVDs, we'll have to sort of wing it when saying, well, because I don't know if, you know, if we read the PVD spec, does a VPN even count as a PVD? It's like, maybe, right? So
right,
we'll sort of wing it a little bit, but I do think using PVD as a sort of like very clear guidance for like physical interfaces is helpful because that's well defined and it's like, you know, we should do that. For VPNs, maybe we just have special case text that says, well, do this, even if it doesn't quite mesh with the PVD. Right. See.
Okay.
I mean, I can't remember the text, but I remember us spending like collectively a lot of time on it, and it seemed kind of to do what it needed to do. So maybe we should like leave the text there.
Yep. Okay. All right. So we'll get some more comments and discussion. Jen, you'll help on that. And then I think we'll add back in some treatment of split tunnel DNS onto this PR, and then please help review so we can get it merged soon. Okay. Good. That was that. All right. One of the other open PRs is around the selection of DNS server addresses. So this is one where I, again, want to get input and feedback here. So Happy Eyeballs v2 had this text. This is something that we inherited from that RFC for essentially saying, hey, you know how you really like v6 addresses when you connect? You should also like v6 addresses when you do your DNS resolution, if you have a choice. So this is about what you use to talk to pick your DNS resolver itself. There's a draft in DNS op that says some things about DNS server address selection, which is really just deferring to RFC 6724, but it does not talk anything, as far as I can tell, about preference between the address families. It's just normal sorting. So whatever you had in your original list, whatever was at the top would probably stay at the top for whatever your preferred, whatever the address family was. So this PR just is a slight modification where it points to these documents and then says that you can sort the preferred address family, which is v6, up to the front before running the rest of the sorting, and that you penalize non-responsive DNS server answers, server addresses, and you would switch over to the next if you realize that a particular recursive resolver was not being responsive. And this is just essentially describing what Apple's MDNS responder has done for quite a while, and that's where this came from. So I think there's probably like, what do we think about this? I think there's some question of like, does it even still necessarily belong in here? It is essentially just applying the happy eyeballs philosophy to this other step of it, but it is a bit separate from the connection establishment logic itself. Lorenzo.
So I don't think it's true that 6724 doesn't have any sorting preference across the rest families. That's what it does, right? So 6724 will says something like, well, prefer native IPv6 if you have it, but if you only have a ULA, prefer IPv4. So that's like actually very opinionated about v4 versus v6, and it
Okay.
doesn't sort the families one ahead of the other. What it does is it looks at like the set of address pairs that you have, and then it sorts those. And so it is de facto a superset of doing something very simple like what you have here. So what I would say is either we sort of leave this unspecified, right? Or we say, because I think looking back, I think I might have been the one that made the suggestion of using 6724 for 3901 BIS. I can't remember what the corner case is that they were trying to solve with that document, but we basically ended up saying, well, if you need to make some decisions on sorting, you might as well make the same decisions to talk to your DNS servers that you would for talking to any IP address. And so I feel that there's value for the sorting to be consistent. So either we say nothing, or I think we should say 6724 BIS.
So I think we could just point to these docs and say, 6724 BIS has the effect already of sorting this up if it's appropriate.
Yeah.
I think it's still useful potentially to discuss, what happens if
penalizing I think is fine. Yeah, penalizing.
So keep the penalizing.
Yeah, but I think in terms of like, just like a sort of DNS lookup will give you some set of addresses, and you'll have some set of source addresses. When you do a DNS lookup, you'll have some sort of server addresses, and you have some set of source addresses. You just the same sorting there. And yeah, penalizing non-responsive. Yeah, that definitely is advisable. I think we should have text about that.
Great. Okay, so we can update that. Ben,
go ahead.
Hi. I just put a long comment on this PR like 2 minutes ago. But I think the bottom line for me is I think that we should try to stay out of this. The DNS connection, like optimization, is really a different problem space from this. And even where it's the same, it can be structured separately. And I think that's better. It's easier to understand. So I put a long comment about what I think is actually needed here. I just want to repeat here that this is talking about IPv4 and IPv6, but DNS has something like 6 different specified transport protocols currently, and there's lots of interesting questions about how you choose between them. And I think that ultimately would be a great place to use happy eyeballs. But I don't think that happy eyeballs needs to sort of transitively include that into the definition of happy eyeballs. So happy eyeballs can use DNS. There's a hard abstraction barrier. We don't know what goes on behind the curtain. And then DNS can be a customer of happy eyeballs too.
Yep, it's true. Okay, so I think that option is just like remove all of the discussion of that. So I guess I'd like to get a sense from the room of like, would we prefer to just remove all mention of this, or do we do something like we were discussing just now with Lorenzo of like saying like, yeah, look at these. Look at this other spec for how you select your resolver, but then still keep in some mention of the fact that like you can still penalize, and like they just kind of non-normatively describe how the resolver selection can fall back like happy eyeballs. I'm happy with either.
So my preference would be something like to say where DNS resolution is performing service B connection establishment, it can also use happy eyeballs as specified here.
Eric, and there's also a poll going on, so chime in.
I was going to kind of support what Ben said. I think there's enough corner cases here, like and issues that if we started to expand on this, we could easily turn it into its own draft. And there's a bunch of stuff that's covered, like some is covered in RFC2B 10,001, but not everything. But I think, as Ben was suggesting, some of these we may want to get pulled out separately.
There's not a lot of opinions on the poll.
What is 10,001? Sorry, what does it say? Oh, 3901 bis. Right. So I think one thing that 3901 bis doesn't say is like, should you sort a DOH server before a plaintext server? And the question that I have here is, should this draft say something about that?
For which like
in
DNS
HEV3, should we say something, anything at all about saying, well, we should use DOH over non-DOH?
No, I don't think that's this doc. I think that gets way bigger.
Then maybe, we just punt on the entire thing and say that, we use a system dependent or whatever implementation dependent DNS resolution routine.
Yep.
That's the way the poll's going, I think.
Andrew Chenka. I think that the question of DNS server selection is not even address family specific, because I did have the operational experience of having 2 IPv4 only DNS servers, and if one of them was down, it was not optimal. So I think there has to be some description of how that should work. I don't know if it's in this document.
Stuart?
Stuart Jasher from Apple. With spec text like this, I tend to have a preference to have some explanation, non-normative text, but just a couple of sentences, because everybody in this room that's heard all the discussion knows the background, but somebody new picking up this document and reading it might wonder, how does this interface with how DNS works? And just having a paragraph that says what you want to say about trying different paths or different mechanisms concurrently, asynchronously, whatever you think is useful background, then that reader says, oh, I get it. Maybe I have to refer to some other document for the normative definition of this. I do find those little bits of supporting text helpful in understanding the overall philosophy of why we're designing things the way we are.
I think that's a fair comment, as long as it's not too giving too many hints, maybe.
Yeah. Okay. It was good input. Thank you.
Right.
All right. And the very last bit, this is a open issue from Max, so thank you for that, based on Firefox telemetry and implementation discussion. So this is talking about having a exponential connection attempt delay, essentially exponential backoff here. So it's based on, I think, where you have a notion of like a fixed delay that you would use. And I think previously was using like a fixed 250 millisecond delay. And this was about moving to a shorter delay and then backing off from there. This is something, admittedly from my perspective, where our implementation is not using fixed delays, and it's using historical estimates for when you have a TCP retransmission. This hasn't come up there. So I think one question is, how much is this specific to using a constant delay? Should we be just changing some of those recommendations? Does this also apply to cases where we would have the delay based on the expected RTT and the retransmission timers? I think there are questions about, should we cap how far we would back off and extend delays in the race? And I think also it'd be good to look at more measurements around this. Max, do you want to talk about it?
Yeah, Max Mozilla. I'll cover this more in my talk in a bit. In general, I don't have a strong opinion. Whatever value we choose, it's going to be the wrong one. I think 50 milliseconds is not so relevant, but the exponential backoff. In general, I think the draft already includes the idea of you need to implement your own mechanism. So I think 250 milliseconds, at least for Firefox, is very conservative. That's why I'm suggesting 50 and an exponential backoff.
Okay. Lorenzo?
Sorry for doing this, but on the previous point about DNS servers, I know you made it like a shocked face when I said do we need to say anything about sort of encrypted DNS resolvers? I guess one, which, you know, I'm not going to challenge that, but I think one thing I would like to say is, do we think there will be no dependency in the happy algorithm on, for example, whether a query was issued, whether an answer was received over an encrypted transport, and should that be preferred? It's fine if we leave that out of scope. I'm just saying if we think the algorithm would benefit from that, we should at least think about that. And I concur with Stuart. If we sort of leaving it unspecified and having some text saying like, here's some things you want to think about is good too. But
I think it's mainly interacting with ECH and how much you trust ECH there. But I don't know.
But like ECH itself, basically, kind of, if you in order to do it reasonably, you kind of like have to know whether the query was, whether the answer is encrypted, right?
But I think there's a difference between knowing whether or not you use an encrypted transport and being able to control or influence that.
Sure. But it's a bit, it's probably not a big step. But anyway, if all we need to know is whether it was, whether the answer was encrypted, maybe that's fine.
Yeah.
I'm just thinking, you know, we might decide later that, oh, oops, we deleted this text, but now we need to know. And so.
All right. Nidhi.
I think we're running low on time, so I'll go quick. So to the questions, I think this is a good idea. We should consider maybe doing the exponential backoff, although I think we should cap the backoff. In Chrome currently, we do, in the newer code path, we do a static delay, but we are changing towards a more using the historical RTT information. And I think the 250 milliseconds is probably carried forward from the second version of the draft. So we might want to look at the RTT information again and try to update that to be a better
updating the default there.
Yeah.
Sure. Yeah, that makes sense.
Cool.
Andrew,
the queue is closed actually, but if you want to hop into people, it'd be good to chat more after the session, but we got to keep going. Thank you. All right, Gautam, are you ready? So this next one we're doing before some of the implementation reports, because some of those reports reference the concept of optimistic DNS. There's going to be another conversation about optimistic DNS in DNSOP on Friday. So the 10 minutes that we have here is not going to be enough for us to fully get all the way through all of our thoughts about optimistic DNS. So we're going to time box that rather strictly here. I very much encourage you all to have lots of conversations between now and Friday. And then on Friday, we will revisit the topic in DNSOP. Sound good? Hold that thought.
Thank you. So as Eric mentioned, this was very much designed as a speed run to talk about optimistic DNS, since it's going to be referenced quite a bit. And this draft was actually a result of conversations that happened in this very working group, where we were discussing how does optimistic DNS sort of interact with happy eyeballs and what influence does it have on happy eyeballs. And as we were looking into it, we realized there was value in formalizing optimistic DNS into its own draft. So for folks who are wondering what optimistic DNS is, the short description that I would like to give you here is that it's a client-side stub resolver mechanism that will return expired cached DNS records, and then in parallel is going to refresh the expired answers by making a new query. Before we sort of go ahead, I want to talk a little bit about why do we want to use expired DNS cache records. And as most of you might have guessed, it's primarily for performance reasons. So when you're making a new, when you're looking up a new domain name, anything, you are going to pay the network cost, and that latency is expected. And the good news is that when every subsequent lookup that you do for the next TTL, in this case 60 seconds, you are going to hit the cache, and you're pretty much, that lookup is going to be free. And that is going to be true for the next 60 seconds or so. And somehow at the 61-second mark, this answer that was perfectly acceptable till a second ago suddenly becomes unacceptable. And now we are expected to go and refetch that answer. And in most cases, in the common scenario, this answer has not changed. And so now we have unnecessarily taken the performance hit for an answer that we know has not changed, And the way we have designed sort of think about optimistic DNS is in the short form, the application that has opted into optimistic DNS. So it knows that it might be receiving expired answers. Queries a stub resolver. The stub resolver, if it has expired answers, is going to return those to the application immediately so that the application can start connecting right away. And the important bit here is that it's also going to send a query in parallel to the DNS server so that it can refresh its cache. And on receiving the response for this, if the answer has changed, then the stub resolver can essentially let the application know that the answer has changed, and then the application, if the connection attempts using the previous expired answers have not succeeded, can now use this new answer to actually make the connection, make the new connection attempt. So in the best case, we have eliminated the latency, and in the worst case, the cost that we're paying is a failed connection attempt. And I think there are a couple of things that I'm implicitly assuming as I'm describing this scenario. And there are two enabling technologies here. The first is the asynchronous DNS. We're assuming that the application will continue getting updates from the DNS query even after we've handed it off the expired answers. We expect the application will continue getting answers even after, so that we can, if the answer has changed, it will get a new set of answers. And the second is happy eyeballs, which means that the application will continue trying new addresses. And in this case, the fresh answer that it gets from the network, so that till a connection is successfully made, is going to keep trying. And a succinct way to sort of put all of this together is that asynchronous DNS makes optimistic DNS possible, and happy eyeballs is what makes optimistic DNS safe, which is essentially saying that if your application is not using asynchronous DNS and happy eyeballs, we do not think it is wise to use expired answers. So this is we know we are using expired records, which seems like a big no-no for a lot of folks, but this is doing it in a responsible way. Yeah, trust me. This draft is essentially based on the experiences from implementing and deploying optimistic DNS in MDNS Responder, which Stuart and Phil have worked on quite a bit. And as an implementation, MDNS Responder, which is an open source project which ships on all Apple devices, has been shipping this since 2018. So if you use an Apple device, you have been using expired cache records for a very long time. Sorry. Just knowing it makes it real. And as you will hear in the implementation updates that will come up next, Mozilla and Google are also working on sort of tying in optimistic DNS into their implementations. In terms of next steps, this is something that we have been wondering. The draft is currently targeted towards DNS op, but optimistic DNS, in our opinion, only makes sense in the context of happy eyeballs. Without happy eyeballs, we don't think optimistic DNS should be a thing. Given that, we could make an argument for optimistic DNS to live inside the happy working group. And if folks have strong thoughts about where this draft should live, that should be a conversation that we should have at this working group. Okay, thank you.
All right, we have about 2 minutes for two very quick comments. And then, as we were saying earlier, we encourage you to use the entire week to talk through a bunch of this. We'll also talk to some of the DNS op chairs and such to sort out some of the dispatch question there. So 2 brief comments, go.
Eric Nygren, thank you for writing this draft. I think it helps tease out where I think is kind of the disconnect is I think there's two different things we're talking about. There is the grace period to go over your TTL by a few seconds to handle some of these race conditions, which is totally reasonable. And I think it's just we should do it. Then there's the ignore TTLs for 7 days thing, which has massive operational implications. And I think where operations is going to be major stakeholders in that. And I think has a lot of security and privacy implications, even if you do happy eyeballs. So maybe if we kind of pull those two apart, it might be easier to have those as two separate conversations.
Sure.
We learned in the V6 renumbering work that there's a lot of that out there.
Hi. So in the slides, you presented this example with like 60 seconds and a request that comes in right after those 60 seconds, resulting in a latency spike. I think for DNSOP, I'd like to see that example made a little more realistic, because in the real world, if you have frequent requests, then you have an open connection that remains open and doesn't, shut off when the TTL expires. So I'd like to see a more realistic presentation with more realistic numbers about what we're actually talking about in terms of stretching. Overall, I would say my preference would be for this to be opt-in. Domains that want this behavior can set a flag in an HTTPS record and even maybe provide some parameters.
I don't think I caught that, but I can follow up with you later.
Right.
So yeah, just an HTTPS service param that lets the domain say, you can be do some optimistic stretching on this name for up to 2 hours past expiration.
Great, thank you.
Thank you very much. Max, I think you're up next.
Should be.
Hi everyone, I'm Max from Mozilla, and I'll present again the updates that we have on Firefox, more specifically Happy Eyeball v3 in Firefox. Since last meeting, we now enabled Happy Eyeball in Firefox nightly. This means that we have roughly a population of 15,000 very brave Firefox users running Firefox nightly, and we have the telemetry of that. And that's my main contribution here, where I can share all of that telemetry here. And in the slides, you have the links. All of this is public, so you can look it up yourself afterwards if you want. As a summary, like we're tracking the draft quite closely, but we have a couple of deviations which I'll present. If you want to try it out yourself, download Firefox nightly. That's basically our alpha version. Confirm that Happy Eyeballs is enabled. It should just be on by default. If you're running an old version, then it might not. And then visit any website, for example, the happy-eyeballs.net website. And there you can test our implementation, but also any other, of course. On some resolvers, we don't have good HTTPS record support. Or if you want to boost your probability that you get HTTPS records, then try DOH. Okay, all of this is implemented in a reusable library. It's on Mozilla/Happy Eyeballs on GitHub. It's not aware of what Firefox is, so you can reuse it in your software. It's deterministic, it doesn't have I/O, and it doesn't have time, so you can pass all of that in. And all of this allows us to write really nice tests where we have all the properties of the draft encoded in a unit test. So, for example, if you don't want to use our library, you can point your agent at our test suite and then port that to your language. The draft has two timers, the resolution delay, the connection attempt delay. We currently, for the resolution delay, the draft suggests 50 milliseconds. We currently do 25 milliseconds. I have another metric landing soon, which will allow us to do an even better informed decision, and we might drive that down even further. And then on the connection attempt delay, the draft, as shown in the previous presentation, suggests 250 milliseconds, and we do 50 milliseconds with a 2x multiplier. On the bottom here, you see the timeline where we do at T0, we do the first one, T50, do the second one, T150, we do the third one, and so on. Okay, down into the metrics. Yeah, as you can see, our P5 to P99 is varies a lot in terms of connection establishment in Firefox, as in like Firefox runs in very fast networks, very slow networks, to very far away origins, very close origins. You'll see 10 seconds as the cutoff on a lot of these metrics, as it's simply me saying like after 10 seconds, I don't care about the metric anymore. So that's the cutoff. It might be higher. Our connection failure should be 30 seconds, so a little bit beyond that. In terms of failure up until the 75th percentile, we detect quite fast. I assume this is either the operating system telling us there's no connectivity or the first hop or the like. But then also the long tail, we do need quite some time to determine that we have no connectivity to the host at all. This is, I would say, the most optimistic slide of Happy Eyeball overall. Our winning attempt index, as in which of the many attempts we do succeeds, is the first one in 84% of the cases. Now, this could have two implications for us. Either we have a really good implementation, or two, we're not aggressive enough. And I have a couple of ideas on how we can be more aggressive later on. In terms of connection attempt count, how many attempts do we actually make? Here again, we only, in 86% of the cases, we only do one attempt, as in it almost always works. All of this work is only for the long tail. Cancel the attempt count, again, pretty much none in most cases. Time to first attempt, that's between we decided we want to connect and we do the first connection attempt. So basically the resolution time. Here you see in the P50, 3 milliseconds. That's mostly just served from cache, either in our cache, the OS cache, or the recursive resolver cache. And then, yeah, this grows quite far. P99, 600 milliseconds just for DNS is quite long. Here, I have this later as well. We do optimistic DNS in all of this. We have been doing optimistic DNS actually since 2013. So that also explains the P50 of 3 milliseconds. Okay, DNS resolution time by record type. Not particularly, I just want to show here, there's not too much of a difference. We oftentimes see the quad A slightly delayed from the A record. You see the HTTPS record significantly faster here in the metrics, but that's simply because in most cases we don't have an HTTPS record, and so we simply cache the negative and then serve that. Yeah, one major motivator for us to do all of this is to increase our share of HTTP3 traffic. So how can we learn about HTTP3 support on the origin? Two mechanisms, alt service or HTTPS RRs. In 35% of all connections, we upgrade due to a signal in alt service. And if you break that down on all H3 capable hosts, that's 84%. And in very rare cases, we see an HTTPS RR record. I'll go a little bit more into that. When we do get that HTTPS RR, in most cases it has an H3 ALPN. I assume that's also the main motivator by operators to deploy the HTTPS RR. We do see hints, and in some cases we see ECH. In terms of HTTPS RR features, by resolver, Firefox supports DOH and native through the OS system calls. There's not much difference. Back to the idea of H3 upgrades. Again, there are two ways, alt service and HTTPS records. We as a browser want to see more HTTP3 as it, for example, way faster connection establishment. The problem with alt service upgrades is that we waste a whole round trip. We first have to do an HTTP2 or HTTP1 connection, then we get the alt service, and then on consecutive connections, we would do the H3 connection. With HTTPS RRs, we can do HTTP3 on the very first connection and thus get all the benefits of the very first connection. So this is really important for us. And that's why I started a little effort, savearoundtrip.com. You can check your domain there, whether you publish an HTTPS record, whether you publish alt service RRs, what the numbers are in terms of Firefox, what we see normally. And you see it will attempt quick to it and see whether your endpoint actually speaks quick. So would greatly appreciate help circulating that widely, and so hopefully see more HBSRs. Right, back to Firefox. How do we deviate from the draft? We changed the attempt delay, 50 milliseconds to X backoff. Overall, we saw good improvements from that. The resolution delay for us is 25 milliseconds. We're considering tuning that downwards. The draft right now specifies interleaving IP families. That's very important, right? You don't want to walk through all of the v6 addresses and then try v4 only to find out that you're in a v4 only network. But we also interleave protocols. So we would try quick v6, quick v4, then TCP v6, and then TCP v4. We already do optimistic DNS. And in the future potential deviations, right now we have the the resolution delay, the 25 milliseconds. We wait up to 25 milliseconds after we got the first positive response for both our preferred address family and the HBS record. And I'm considering the idea of not waiting for the preferred address family. Most of Firefox's connections are very short-lived. Now maybe v6 is faster, as in the connection later on will give us the bytes faster, but will it make up for those 25 milliseconds that I waited for the quad A record, up to 25 milliseconds? So that's the discussion to be had. We had this discussion, Lorenzo, that this might introduce a race where then Firefox switches between v4 and v6 all the time. In general, let me say, like, if we have both, we would always prefer v6 unless the user configures it in a different way. In terms of potential future additions, Happy Eyeballs allows us a lot more optimizations, as in we can be optimistic in a lot more places as we now try to attempt a lot more other things. What would be interesting is to, for example, make our Happy Eyeball state machine proxy aware. So when you proxy, you have a connection to the proxy and a connection to the origin. So the cardinality explosion that you already have to the origin just blows up ×2 because you have all these connection options to the proxy and you have all these connection options to the origin. So we might introduce that, some of that into our state machine. And then the other one, currently Happy Eyeballs is not aware of the last application protocol, as in WebSocket or web transport, but we might introduce that into the state machine as well, and then raise different connections, whether we can, for example, do WebSockets over them. Yeah, a couple of edge cases that we hit. DNS negative answers is quite difficult, especially as we don't have TTLs for those on all platforms. DNS coalescing. There is some multi-CDN trickery around CNAMEs and HBSR records. And then a big one for us as a browser, the web standards. We emit various timings, and we really wonder, where does DNS lookup end? Where is that? As in, like, is that... So this is really difficult. I think Kasha implemented a really good solution in Firefox, but I think we should probably standardize across the browsers on that. Okay, and then I still have a little bit of time. A big discussion here from operators is, how do we debug Happy Eyeballs, and doesn't this make it super difficult to find any bugs and in our networks? And what we can offer from the Firefox side, and I'm sure a lot of other browsers also expose a lot of debugging tools, is various ways how you can introspect why Firefox made certain decisions on the Happy Eyeball path. So first, on the very left here, you see about networking. There you find what kind of connections we do. You see our DNS cache, our alt service cache, so you can reason about what Firefox had available. And then on the right, I'll also show a screenshot in a bit. Firefox also has the ability to capture traces of the Happy Eyeball execution, and then you really learn the reasoning of the state machine and why it chose certain path. In general, I already talked to Mirja. We could also extend this to emit Q logs for Happy Eyeballs then in those traces, and that can then be a standardized way for operators to debug. Here, just a screenshot. You see a Happy Eyeball execution. You see that Happy Eyeball got an HBS record in quad A and A, and you see that the HBS record took slightly longer than the quad A and A. The state machine waited, and then decided to emit an HTTP3 connection over v4. I was in this case on a v4 only network. And that succeeded, and then we didn't trigger anything beyond that. So just as an example, in case you want to learn more, find me anywhere, and I can help you debug happy eyeballs in your network with Firefox. Cool, and then last thing I said earlier, we almost always win on the first attempt. So either our implementation is good or we're not aggressive enough. We can now be optimistic about various things. So we already do optimistic DNS. We've been doing that for very long. We could, for example, be optimistic about alt service and keep those beyond the TTL. Again, revalidating. And we can do optimistic quick. None of these are happening in Firefox today. All of these would have experiments and so on, but just ideas here. Cool, that's it for mine.
Okay, we'll take the 3 questions in the queue. We're pressed for time, as Eric said at the start, so take anything substantive.
So Lorenzo Galidi, one of my questions was, in fact, why no optimistic quick? So you already answered that one. So I'm curious, given you have so much telemetry, it would be great to know if you raced the first address with the first address, how would your metrics change? In other words, how much of this is just the statistics of like hammering the network harder versus the first address not actually working? I would love to see the answer to that, because we're building something really complicated here. So your second attempt succeeds, but that whatever 8% of the time, right? Your first attempt succeeds 91%. I can't remember exact numbers.
Yeah.
But if you replace the second attempt with the same IP address as the first attempt, how many times would that actually work? I suspect it would work almost 8% of the time. And so I guess what I'm saying here is like, how much are we doing diminishing returns? Maybe Tommy has an answer to that. The other thing I had to say, but like, I think we should try to do that, because otherwise, because it will give us an upper bound on the utility of this whole working group. Sorry. All right. Okay. Now you can all shoot me. Sorry. But really, if all we're doing is like sending more packets, let's just send more packets, right? So anyway, so I really am fascinated. I would really be fascinated to get the answer. The other thing I wanted to say, more related to what we're trying to do here, is you interleave protocols, because that's kind of easy, right? V4, V6. Now, the draft says, let's do 6724. And I think you probably looked at that and you're like, oh my God, that's hard, right? And so I wonder whether we should say something else in the draft. I mean, it's the only thing that's correct, I feel, but it's very hard to implement in user space. And it's on Android, it's very difficult to do that at all without latency penalties as well. It's just very hard. So I don't know what to do about that. But
Tommy Pauly. I don't have solutions for you, Lorenzo. Okay, so one question here, you mentioned briefly earlier on the HTTPS record usage being low. I guess, how low and why?
Usage is high, we don't find them. As in, whenever we have an HTTPS record, we will use it.
Yeah, but like,
in most cases, website operators don't publish an HTTPS record.
How often are you seeing the response come back?
I think almost always, yeah.
No, with content.
With content.
With in a non-empty response.
So for a connection attempt, only in 3% of the cases, well, if you add those two, it's in 7% of the cases do we actually see an HTTPS record.
And is that, like, do you know that you're actually getting the query out in all of those cases?
I assume so. Obviously, we could have bugs.
Sure. Or blockages. And is this the raw number of connections, or is this separate host names?
This should be one connection attempt, so per top-level site domain.
Okay, for a top-level site.
Sorry, per domain that we're trying to connect.
Okay. Oh, but per domain, not weighted by the number of connections to the domain.
Not weighted by the number of connections.
Or
okay.
So let's say Google.com publishes it.
Yeah.
If if people go to google.com a lot, is that going to increase the number or is that not going to increase the
It's going to increase the number.
It will,
This
okay.
is per connection establishment.
Okay.
As in per happy eyeball processes.
Because I was looking like our stats for browser workloads, I'm seeing a HTTPS response for 17%.
Positive or negative?
A positive response in 17%.
Okay.
And then in 30% of those cases, I actually see that it causes us to upgrade to H3 when we wouldn't have otherwise. So we didn't already have alt service cached.
Okay.
So it's pretty different numbers there.
I would still hope for more than 17% overall, but yeah.
But that's a lot different than 3.
Yeah, we need to compare those numbers.
Okay.
Like I see very little HTTPS records, and I also, when I compare this, just like trying it out through Cloudflare's recursive resolver, like DOH endpoint, I also rarely see websites publishing.
Okay.
DOH.
All right. And then
Sorry,
one other
HTTPS
comment
size.
for your proxy explosion.
Mhm.
I think the way I would suggest solving that is just connect by name through the proxy. Don't do happy eyeballs inside the proxy.
One more question. It might be an online one. Very, very. Oh no, you're here. Very quick.
Yeah. So I think it would be useful to quantify the increase in network load. So as Lorenzo was talking about thrashing of the network, so it should not just be about doubling or quadrupling of packets. It would be also useful to quantify the protocol flapping. How much flapping do you see between the protocols? That would also be useful. And I think given that you have data, it would be useful to segregate the results by network type. Show how the results look for a fixed line network versus a cellular network, 2G, 3G, 4G. Then it would be more useful to identify what should be the timer value. I think we should not stick on one single timer value. Otherwise, we'll be again in 5 years talking about happy eyeballs version 4. And I'm speaking from experience because my PhD was on happy eyeballs. 10 years later, we are still talking about happy eyeballs.
Okay, sounds good. Thank you very much, Max.
Thank you.
Thank you, Max. Kenichi, I think you're up next. And you wanted the revised version.
Okay, so I'm Kenichi Shibashi. I work on Chromium network stack. Today I want to give a status update on happy eyeballs in Chromium. So let me start with a quick recap. Chromium supported only happy eyeball version 1 and only for TCP. TCP and Quick run on the separate code paths and each do its own DNS resolution and wait for all DNS responses. So we want to improve the situation, and we said we were reworking the connection management layer to fix the situation. So develop a single cross-protocol coordination algorithm, share DNS resolution between TCP and Quick, start attempt without waiting for all DNS responses. Since then, we have been implementing this work in stages. So here's the overview. Everything built on top of a new async DNS resolver, which pushes a partial result as each answer arrives, considering the resolution delay. On top of that, we are moving forward with the staged approach. So we are improving the TCP and the Quick code path separately, and then we work towards developing unified cross-protocol coordination. And in parallel, we are implementing optimistic DNS. So let's start with TCP. So now TCP connection attempts consume incremental resolutions. So that means we connect as soon as a usable address arrives without waiting for all DNS responses. So the resolver applies the resolution delay from RFC 8305. So when cloud delay is still outstanding, it holds IPv4 only result for 15 milliseconds. As before, we raise IPv6 and IPv4, so that the race just starts sooner. And we are about to shift this behavior, and we saw a measurable performance improvement for our services. So next, quick. Currently, a quick attempt to wait for all DNS answers, just like the old TCP behavior, and tries only a single IP address. So if that address is unreachable, Chromium falls back to TCP, even when Quick would have walked over the other address family. So this isn't a good situation. So we want to fix that. We are working on fix that. So Quick will get the same behavior that the current TCP already has. So that means we start the handshake as soon as the usable endpoint arrives. And if the first attempt fails or is slow, attempt the other address family. The first attempt to succeed wins. In parallel is improving the TCP and Quick code passes. We are also implementing the optimistic DNS. So we already had the presentation for the optimistic DNS, so I won't go into details, but the idea is to start connecting with the expired DNS cache while simultaneously creating for fresh DNS responses. So how are we implementing this? So on the resolver side, we've done the groundwork. We added a new cache usage mode, the long name on the slide. In this mode, the store addresses are served as an intermediate result, while flashing resolution proceeds. And the final result is always fresh. So regarding the connection attempt layer side, so TCP is largely implemented, and we are planning to do a field experiment. For Quick, we plan this as the step after moving to incremental resolution. What remains is a unified connection management logic across protocols and address families. So we actually started with cross-protocol coordination first, but we learned a lot. So the racing part wasn't the hard part. So the difficult part was that the existing code path carries years of optimization and keeps evolving. So the rewrite has to keep chasing it. And also, in some edge cases, the new code path makes connection attempt stall or come out slower. So all of these are solvable, but users should not have to wait for the whole rewrite. So that's why we decided to go through the staged implementation and tackle the cross-protocol coordination later. How do these works map to the V3 draft? So most of the draft's individual behaviors have been implemented or are in progress. So incremental resolution, connecting to the partial results, resolution delay, address family racing for TCP and Quick. So the remaining is the cross-protocol coordination, just I described in the previous slide. Yeah, and to summary, so yeah, we are shipping hyperable V2 behavior, and Quick improvement and optimistic DNS are in progress, and we plan the cross-protocol coordination later. Yeah, that's all I have. Thank you.
Great, thank you very much. We're only 3 minutes behind, amazingly, so time for a couple of questions to make sure we do get further behind, if anyone's got any. We'll just, yeah, there's 2 questions, so we'll take those and then we'll move on if the next person wants to come up.
Hey, Johannes, MPI. One question, do you plan to raise Quick against TCP or Quick against TLS on top of TCP? So is the signal the TLS handshake that is successful, or is it the TCP handshake that is successful?
So currently, we have totally separate code paths between the TCP and the QUIC. So we plan to unify it, but currently, so we basically raise both paths at the same time. So there's no interaction between the QUIC path and TCP path. Does that answer your question?
No, I think that's where the signal ends. Like, is it once TCP is successful or once then TLS on top of TCP is successful?
So Nidhi, you want to briefly talk about?
I think so. To answer your question, we wait for the TLS now to mark it as successful.
Okay, thanks. And Ben, if you want to come in.
Hi. So for optimistic DNS, how stale is too stale? At what point do you cut off stale records?
I've heard this question before today.
So would you say that again?
You're going to hear it again.
So for your implementation of optimistic DNS, how long are you willing to hold on to a stale record?
So I couldn't do that. Sorry, I'm not very good at hearing. So could you say that? Would you rephrase the last part?
It's the trouble with remote questions. If a record is stale in cache, is there a limit where you'll just delete the record or decide that it's too old?
We have several signals to remove the cache. First, we don't persist DNS cache. So every time Chrome relaunches, the cache is cleared. And another is like if we got the network event changes or something, we also mark these as stale. So yeah, so that's.
Okay, that's interesting because then on say a desktop version of Chrome, it could be up to a few weeks old.
Can be, yeah.
Okay. Let's see. I wanted to voice my continued desire for Chrome to implement the service B target name capability. I hope that this work helps to clear the way for service B target names.
Yeah, I know you are very interested in that support. So yeah, I hope at some point we can work on that.
And I wanted to ask, what will happen if a quick is attempted, and after 50 or 100 milliseconds it hasn't completed yet, and you start TCP? If TCP and TLS wins, will you cancel the quick connection?
No, we don't cancel quick attempt for right now. So we let the quick attempts go, so that the next request can use quick, hopefully. So if that succeeds.
Okay. So I think that's the right behavior, and I think we should make sure that we've talked about this before. I call this connection escalator. We should make sure that the Happy Eyeballs v3 text supports that behavior.
Okay, thank you. Let's move on and get Tommy up. We've got Tommy, then we've got the web tester report. There's been some hackathon activity, and then we're on to the reporting.
All right, speedrun. We've talked about a lot of this before. So HEV3 implementation on Apple devices. This is evolution of what we had for Happy Eyeballs v2. This is all based on historical RTT data, not fixed timers normally. Recent numbers showing that overall, this is for everything, not just particular loads, we see 97% of things using the first one. So usually we don't need this. That's good. the SVCB support was added back in 2020, and that's when we had the ALPN processing. So I just want to give a brief timeline of some of the updates here, because there are a couple changes in the betas that you can test out. So it was back in iOS 25 when we started always sending the A queries for NAT64. So this V6 stuff that we're doing, it's been a while coming. We fixed shuffling of SVCB records that have the same priority a little bit ago. And then on the current things that are in beta, that if you want to test them out on the developer or public betas, that includes only reordering happy eyeballs within SVCB priority groups before it would cross. So we would reorder V4 and V6 potentially across different SVCB priorities. And now that will not happen. They will respect the priority. We're also collecting a bit more data around the resolution timings to help inform if we want to update the timers. So as one example of this, and we can get more data pulled out, but Max was talking about the resolution delay timer. So what I just pulled this yesterday. So seeing the difference, at least between when we see A and quad A come back and looking at like the absolute value difference between those, almost always they're at the same time. P90 is only 17 millisecond difference, P95, 34. P99 is out at 100. Currently, we have the timer at 50, so it catches most things. I think kind of it'd be good to compare notes on what we see on different implementations. Do we agree on what the curve looks like here for when we see these come back? And how do we want to use this to influence where we set that timer? Okay. So yeah, we'll continue to update as we make changes to the spec and we get feedback here. We want to keep collecting metrics. I think one of the things based on what Max was talking about that we'd like to start collecting is about how many connection attempts we started but didn't end up using. So like how often does the first connection attempt win the race, but we started a second one and had to cancel it. We don't currently capture that. We collect just which one won. That's all.
Great, thanks, Tommy. So time for a couple of questions. The queue is unlocked if anyone wants to quickly ask something.
I think in both reports, I saw a lot of focus on the happy path, so which is very nice, but a little bit more on when the failures happen. So when the connection doesn't succeed on the first attempts, and kind of echoing what Lorenzo said, is that would a retransmit solve it, or did happy eyeballs rescue it? So was that V6 failing and V4 fixing the connection and things like that?
Yeah. And like our timers are based on around the time that the retransmission happens, and the other retransmission does happen, right? So like the first thing does keep retransmitting, right? That doesn't tell you if you just kept flooding the same address more, would it eventually work? Hard to say. But again, like it's honestly pretty rare that we have to fail over globally. I think, there's certain network conditions or certain sites that really need this, and that's what we're trying to fix.
Yep. Because what I was saying is that I think the happy path probably overflows the statistics that are interested in the unhappy path.
I see what you mean.
Yeah. Hi. Maybe it's easier for Apple to answer than Firefox for this question. So how much does this drain the battery when you send multiple packets into the network? Might be useful to evaluate that.
Got it. Yeah, I do. I could not answer that off the top of my head. And oftentimes, energy usage is about when you're already spinning up the radio, and when you're aligning this with the time that you'd already be sending packets, it's not going to have the worst effects. That's a good question.
Okay, thank you. So we've had the 3 implementation reports. I think it's very interesting to see, and I think Max highlighted it more explicitly, what the deviations from the draft are in those implementation reports, and how much of that is just perhaps a different tweaking of defaults and how much is something more substantive. So I think we need to look at that. But the other perspective, of course, is from observing with something like a web tester, for example. So we're going to hear about that for a while now. Over to you.
Yeah, thanks. Johannes from MPI. This is joint work with TUM together still. And to be honest, at the moment, it's mostly work by TUM and Tim, who is implementing this. I'm just the one talking and annoying people with it. So we have this Happy Eyeballs web tester. I talked about it already in Montreal, so 2 meetings ago. We did this as a research project, implemented a web tester where you can test your client in whatever network scenario you're currently in. Basically, it encodes parameters in the domain name, and then the server treats those requests based on that. We did it for version 1 and version 2 back then, and are currently extending it to version 3 and additional tests. So this was the old look, but it drastically changed. We already have on the public website a test for version 3. Everything is still encoded in the domain name, so you can change that and test it. We support HTTP 3, 2, and 1 basically, and then we serve a Quad A and HTTPS records, so clients can make the decision. You can configure different ALPN sets in the HTTPS resource record if you want to. And then we basically have a configurable delay for quick versus TLS, so whatever comes there can be done. We just delay the server hello in the handshake. And then we also delay based on the IP version that is used, so whether it's IPv6 or IPv4. We have 2 options to delay that at the moment. One's just for the TLS handshake as well, so where we delay the server hello. You can also configure to do a network delay so that the TCP handshake would also be impacted, but then it's not that fair anymore. So I guess most browsers currently want to test just where TLS is delayed. At the end, it somewhat looks like this. So this is a test result on Firefox, not the current nightly version with the new connection attempt delays, but a slightly older one. What you have in the result is then a matrix of all the tests where on the x-axis, basically, the TLS handshake is delayed for quick versus TLS TCP, and on the y-axis, the protocol version. So it starts with quick via IPv6. If IPv6 is too slow, it goes to quick via IPv4. If quick is too slow, it first tries TLS TCP over IPv6, and then once again, if IPv6 is too slow, it falls back to IPv4. So this is somewhat the default behavior that you expect with a static connection attempt delay and the order quick over TLS TCP and then IPv6 over IPv4. You can use the matrix and run the test on the website, or you can just get the domains that are used, so the configuration you can download and create your own order of tests, or just run one test if you want to. We also added additional debugging or information by now, so we collect a trace of incoming packets on the web server as well and serve that again, so that you see to some degree what we saw on the web server. This is not perfect, depending on whether we actually see a domain and can map it to one specific test case, but you see in which order the traces arrived or the connection attempts arrived. We now, in the hackathon, extended this to also report in which order the DNS queries arrived at our name server to extend this trace. Good. And then we also added a lot of other tests that are not all of the Happy Eyeball stuff, but are related to that. We have a test that quickly shows you whether your browser in your current configuration even supports HTTP 3, so whether it uses or requests an HTTPS record and uses that, or whether it only works with an alternative service header or not at all. Also, all of the following results are Firefox. We added a test whether ECH is used, so whether it also gets the HTTPS resource record there, uses it. If the configuration is stale, whether it does a retry, if it gets a new configuration, or if it doesn't work at all, whether there is a plain text fallback or no fallback at all. We added different tests by now for HTTPS alias mode, so whether it follows an alias in the HTTPS record or whether it follows a port that might be in the HTTPS record. And I think there's also a test whether it follows the target name in an HTTPS record in service mode, just to see what your client currently does. We have a test that checks whether hints are used or preferred over additional A or quad A records if they are there. There is currently a bug in Firefox, or in unexpected behavior, I call you out here, that we found yesterday with this tool, where sometimes a record is used and sometimes not. And then also we have one case where we delay the A record. So quad A is fast, but then the TLS handshake or quick handshake is in theory slow to check whether the connection attempt is tested. And then if a quad A record comes in late, whether that is actually used asynchronously and feed it back into the state machine and test it. Yeah, that's basically it. Happy dash eyeballs. There is apparently a happy eyeballs without the dash now as well. If somebody knows who operates that, please let us know. We would be interested. We don't know yet. It tests slightly different stuff. Most of the tests are not on the happy-eyeballs.net site yet, but on the staging one, you get the staging one here. We don't promise anything there. It might break, but all of the new and smaller tests that we developed also during the hackathon are there. In general, we are happy about all feedback or requests, whether you see other tests as interesting or additional features. So we are happy to discuss this and extend it. Thanks.
Great, thank you. Excellent work. Time for one or two quick questions, if anyone has any. And if not, we'll move on to the first reporting draft, QLOC.
Hi, my name is Mia Kulevind. I can start talking while the slides come up. So part of the charter for this working group is also that we want to work on reporting. The discussion when the group was chartered is that happy eyeballs makes the user happy, but maybe not the network, because errors get concealed. So we want some logging to find those problems and actually fix them. The first step 0 to that is actually kind of getting the errors logged, right? This is very useful for debugging. I think it's useful also for debugging purposes to have a common format so we all can find the same problems at the same time. But then the next step is also kind of to use this format potentially to report out some things and allow other people to analyze what are the problems when the second attempt, not the first attempt, is successful. Again, step 0 is the format. I put a draft out there based on QLOC. It's really an early version. Everything is open for discussion. The slides are not having a lot of details because at that point, I'm not even sure I got everything correctly from the draft. I need to do some more work there. Even my version on GitHub is changed already because I found some redundant, unnecessary stuff. But I think it would be useful if people who actually have a happy eyeball implementation also look at this and potentially implement that, figure out how hard it would be to implement this into their stack, and if I found the right things or not. So what we have is, I said this already. So what we have is what's in the draft, and again, I'm not going through the details here, just to give you an impression, is 3 data types. So one that carries all the information about the attempt itself, which is kind of post address, interface, and so on, but also LPN and service name and these kind of related data. The other one is what's called a policy. That's kind of what you configure, what are the default values in your strategy. And the third one is about the DNS resolution results. And then it defines a whole bunch of events. Like the first one is like when you set the initial configuration or reset it. Then some events related to when your DNS started, when it finished. It covers the net for 6Ks. It's about candidate discovery, like how to put together your list about which candidates you try and when you change these lists. And then it's about when you actually start an attempt, when you finish an attempt, when you resume an attempt, when you have pending attempt, timers, the results, of course. And then we also added one event, which is just like kind of the summary logging at the very end. And this is the only detailed slide I have. This is what's currently the summary logging, but I think this is also more discussion about, like, kind of Tommy and Max said this about what are the metrics that are actually interesting here. So yeah, I'm looking for people who want to work on this with me, who want to implement it. I talked to Max already. They already have event-based logging, and I will look at their format and figure out if kind of things are matching up. And I'm also interested in getting or analyzing more of those data where the first attempt failed and understand what the reasons are.
Great, thank you. So got time for one or two questions. I mean, part of it will be to whom or to where is the data, is these reporting being made and for what purposes, etc. I think we're going to get some of that in Philip's talk after this. For the
Yeah, exactly. I mean, this is step 0 and it doesn't touch this question, but
yeah. That's part of it.
Hi, Lars Eggert, Mozilla. You said operator. Do you mean the network operator or the website operator, or we don't know? So the question. So we can totally log this in the browser or somewhere else, but how does it get to where it needs to be?
Yep.
Is the hard part, right? Not what is being logged. Is like, do you have a proposal for how that happens?
Yeah, I mean, like, I'm thinking about network operators, but like, I think what we need to do is getting the data and understanding where we are, and then we can figure out what's useful. Because I mean, part of the discussion was also that this is actually a rare case, right? That like in most cases, you just take the first attempt, everything is fine.
Yeah, I totally see the problem space, right? Yeah. But I think the proposal is the browsers or the endpoints log something, and that something gets to where it needs to be somehow. And the somehow part is, I think, the hard part, not that what you log and how you log it. That is not easy, but at least well understood, and this is good, right? But I think any idea of like how it leaves the device and gets to where it needs to be in a way that's terrible.
Yeah, I think you're getting on to the subject of the next talk. It's not
but
if you've got specific comments about what's there, then
I want to say one more thing. Right now, I actually want to get some data and analyze it, and that's kind of offline, right? So I can talk to somebody who gives me some data. If we need something that works online or in a different time scale, or whatever, that's something I think that we can answer better if we know what the data are.
Okay, so if you're just interested in like running a thing and getting data out in some locally analyzable format, that's fine. I misunderstood probably because I thought that data was supposed to go like to a central aggregator or something.
At some point, maybe, I don't know. Like, I'm not there yet. Sorry, people.
Is that Ben again?
Is this HE metrics object meant to go in QLog?
Yes.
Okay.
So I mean, it's not really an event, but it's like when you actually finish your happy eyeballs thing, then you just put this kind of pseudo event in there. Yeah.
Okay. Yeah, I think like for the kinds of debugging that I've had to deal with, I would want a lot more information than this. And when I think about QLog, the thing that I would really like is a way to, I think that we kind of have all the information in QLog about the fine details of everything that happened. What's missing from my perspective is, so first of all, maybe there's things that we're missing, like DNS related events. I don't know if we have QLog events for that.
So I think a lot of the debugging you can actually, like, there's also the events, right, when things are actually happening. So you can put your analysis on the events, right? And that has a lot of more information. So this is really just like aggregated metrics.
Right. Yeah. So the aggregation, that's not what I need. But the other thing that I feel is often missing is a way to thread all of these details back together. You have the HE session ID. I think that seems like a really valuable thing to be able to say this, this TLS session over here and this quick session over here, they're actually from a single connection attempt.
Yeah, so we, for some of these events, we put kind of an identifier in there to like cross-correlate this with the quick connection, with the QLogs of the quick connection. But I think there's also more work to do here. Yeah.
I wanted to mention that I have a pull request up for the HEV3 draft that tries to make the connection sequence state machine much more explicit and technically detailed in a sense, which I think really connects with this, because when you're at the point of trying to look at this level of granularity about what is happening, well, we don't the standard doesn't actually specify HEV3 at that level of granularity yet. And I think that we should do that work on the text. So please take a look at pull request 125 on the HEV3 draft.
Okay, thank you. So Philip, do you want to come up while Lucas presumably asks a quick question?
Yeah, just to say, I think this is good work. It's obviously draft 0, and there's lots of kind of things we could bike shed on. For me, it's like the DNS is probably split into its own stuff as a QLog schema, but none of these details matter. Just from my perspective, as someone who's had to debug like Chrome and how it's managed its connection pool and where H3 has failed and H2 worked, I'm looking at those kind of events anyway quite a lot. So having a standard for that, I think, would be really useful. The question of threading of the session IDs and all of this is super important. I don't have an answer, but we definitely need something like that for QLog to be successful in threading, transport, DNS, application, like all of these related things. So good work. Thanks.
Thank you. Yeah, and like we talked about this earlier, like I didn't even think about that. This is like more generically applicable, but that might be a good way to go. Yeah.
Yeah, great. Thanks very much. And over to Philip for.
Yeah, welcome.
You want the clicker? You've only got one slide, or do you want the clicker?
Oh, you can click.
Oh, I can click. Okay, that's very kind of you.
So, we're talking here today. We now change a little bit positions and look into the operator's perspective, and which kind of operators. I come to that later. Now, this draft, in case you haven't read it, is just about the use cases. So who needs insight into happy eyeballs, what and when to report, and security and privacy considerations, basically saying when and why not to report. Between the last revisions, we reworked the use cases and introduced almost more agile kind of description with personas who want or who need information on happy eyeballs. We wanted to describe what, when, and how example match the personas, and more minor changes. So let's look into the personas, or into the kinds of person who wants insights into happy eyeballs. And the first case, we just see developers and users debugging connection behavior from their local system. So they're sitting in front of a browser or a mobile device and really want to see what has been going on during my current session. In this case, is let's say a little easier. You have full application, you have full client control, you have no aggregation requirement, but because you're really interested in the stuff you're actually doing at the moment. And it's probably has the least standardization requirements, because if you're sitting in front of a Firefox browser, you can use the Firefox profiling tools, which I've seen yesterday and really look cool for that use case. And if you're sitting in front of Chrome, you can use whatever tool Chrome has for you to debug that stuff. The second use case is corporate and managed network operators. So we assume in this case the network operator is actually also operator of the device, has administrative control over the device. It may have some aggregation integration requirements, especially fitting into the logging infrastructure, fitting into the client management infrastructure, but it's still, they have administrative control about the device and may or may not already have means in invading users' privacy, even backed up by some legal means or a contractual means. The third use case, we go now back to the service providers. So the first layer carrier that wants to have some insights on why, probably because of their faults, happy eyeballs fail, or V6 or quick connections fail. We have the further downstream case of intermediate transit providers who might want to have insights into why this happens. And finally, we have the content providers and CDNs. So this is not ordered by importance, but by distance from the client. And what I would like to ask, and get quite early on interactive, what I would like to see is whether these personas make sense for you in the room, whether you think anyone is missing in this listing, and whether you have a strong opinion whether we could merge some of these personas for the later discussion.
I think if you get through to the end of the deck, and then we'll have the chat.
Yep,
Probably the best way of doing it.
So
from the chair's point of view, we want to kind of understand the time. So I think a lot of your follow-up on the other 3 slides, I think you've got, are kind of related, and I think we can have that discussion when we get to the end.
You're saying wait with the questions.
Yeah, wait for the discussions to end. I think would be saner for
the second one is when, what and when to report.
Okay, clarifying questions, as Eric says, yes. Other questions, no.
Yeah. But, the second one is
the queue is quite full.
What and when to report. So depends on. I would say it depends on the persona. It depends on the privacy implications. It depends on the security application, and it depends on the aggregation requirements. And I think for further discussion, further evolving of that draft, the interesting question is. Do these dimensions make sense, or how many dimensions for the further discussions are missing? And last but not least, to give us some idea where this could end up, is a list of examples what this kind of framework for discussing the reporting use cases could end up with. So we have the developer use case, and these could end up with Happy Eyeballs output in some kind of development or profiling tools. It could be ended some of the performance logs of the which already exist in various formats. It could end up in the platform logs, so something like Windows events, systemd, journald, the macOS logging. We have the managed way where we can have platform logs or something like Anycast syslog, just as an example. We have the service providers, where we could also think about something like Anycast syslog or an ICMP or other UDP-based thing looking a little bit like Happy Sad, but which Brian promised. We have the intermediate thing where I could only imagine something like Happy Sad. And we have the content providers where we can end up with a complete now the ECMAScript objects, which I say network error logging, and some other frameworks that are already there to report back behavior to the content providers and CDNs. And with that, I'm happy to take first clarifying questions and afterwards start the discussion.
Great, thank you. So yeah, we've got 5 or 6 minutes. We'd like to give Xipeng at least a couple of minutes to flag his draft if we can, but let's see how the discussion goes. It's obviously attracted a lot of people to the queue, including Brian, which I think is good. We might hear some comment from him about Happy Sad as well. So over to you, Lars. Let's see how this goes.
Lars Eggert, Mozilla. I don't have a clarifying question. So if anybody else wants to go first, I can't get out of queue because my laptop.
Just go for it. I don't think anyone does.
I got up when you had the personas up and you asked whether some of them could be merged. So between 1 and 2, I don't see like a material difference, right? And there, I can see like this is what Miriam talked about, like a local developer like wanting to understand what is the browser doing. I fully want to support in some way, and I think if the browser and other endpoint vendors wanted to like find a common format to make that a little bit easier, I would be sympathetic to that. A managed device, for all intents and purposes, the entity managing device is then not the user anymore, but I see this as almost equivalent, right? We can't stop the enterprise from doing what they want to do, so that's fine. For almost everything else there, I have really bad bellyache. Network error logging, maybe, right? Because this is actually like the server, and we went through that battle before, and maybe there's something that can be exposed, but even there, I'm skeptical. And service providers and transit providers, I have no idea why I would, as a browser, want to expose anything to them ever. And I'm happy to be convinced otherwise, but like, I would really focus firstly on the end user or their standard, which would be the enterprise thing, and then maybe to the CDN in some framework like network error logging that exists, but otherwise, no.
And to be honest, I have not strong opinions on whether we need all these use cases. These are the use cases we had discussed or that somebody has brought up. And I think it's important here to come up with a decision or idea.
thank you for being exhaustive, and I'm happy to hear that maybe some of those cases we will disregard.
As the hint is there, do not shoot the messenger. I think they've done a really good job of kind of scoping out what we might do. It's not, Philip isn't saying we should do that. He's just asking the questions. I think Philip and Geordie have done a very good job on, being there to have the tomatoes thrown at them. And so Andrew next.
Yeah, a small question about, do you think there should be a way to indicate that you have a policy of how you think it should work? Let's say you're exposing the content and you're expecting it to work in a certain way, and the happy eyeballs would somehow signal that it works improperly. And that would as well indicate that you're willing to do something about it.
Good question. Haven't thought about that dimension yet. Jordi, do you have something?
Oh, okay. You're in the queue.
Mike Blanche, independent consultant. Thank you for, as you say, putting the exhaustive list down. I think between the two ends of that list have some sort of relationship, right? The user and the content provider and the CDN that's fronting it. The managed network, as well as Lars says, probably if it really is a managed device. Service provider can mean a lot of things, right? Is it, if I'm roaming, is it the network I'm roaming on? Is it my home network? Is it if I'm using a private relay? Is it that? Are they a service provider as well? There could be ways of providing information to those intermediate providers, the service providers and the transit networks, from the endpoints or perhaps from the content provider. A lot of the content providers have web portals that transit providers and ISPs have access to that can expose some of this information, but giving it to them directly, similarly, I have some concerns, but thank you for putting it together.
Valentin Goshu, Mozilla. I would like to note that most of these personas already can get most of this info about happy eyeballs. So like the end users could get it as queue logs or performance profiles. Operators could get it from PCAPs or whatever other network traces they have. And like websites, like the web tester we saw earlier, can do their own thing and get all this information again. So my question is, we already do a bunch of like extra work with happy eyeballs creating new connections. So like, why should applications do a bunch of more extra work to also report of some of this information that all these personas already get?
So this question I can, so if you ever had discussions with operators on happy eyeballs, they say, oh yes, it's awesome that it solved the problem, but it actually hides so many problems that debugging has become quite hard for us. And we have no idea whether we have an IPv6 black hole because happy eyeballs just glosses over that and falls back transparently to IPv4. This is the discussion you have always when talking to operators. Yeah. And here really the case is that we want IPv6 deployment, that we want to make sure that it actually works, and any signal that helps with that is useful. And as an operator, you have no chance on running a PCAP just in case to find out whether someone has an IPv6 black hole.
But even if we did give them all this information, it's no guarantee that it would be actionable, so that the service provider could do anything to fix things.
So I'm pretty sure that the first and the last use case are the most actionable and easiest ones.
Right.
Yeah, so hi, Brian Trammell. I feel like I was summoned to the microphone when Philip said that I had promised Happy Sad. Happy Sad is not a promise. It's somewhere between a threat and a joke. Yeah, so it actually, no, it's more of a thought experiment, right? Like, so what tools do we have for being able to put additional information in those PCAPs that operators are using that they would be able to pull these things together? I don't actually expect it to become a real thing. I had Claude write a security consideration section for the document. It's now 6 times longer. But I think it is an interesting thing to think about. So like, I am going to revive that document and we can use it sort of as like sort of a test study here. If we end up implementing it, I think that's probably an error message in and of itself. But we should think about what are the ways that we could expose this information as easily as possible.
Great, thank you.
Shipeng, if anyone uses it is another question.
Shipeng, if you're in the room, if you get up here very fast, you're going to have about 3 minutes while Jordi asks his co-author a question, which is a bit weird.
Jordi Paulette.
Just for context, I am the troublemaker with this. I think it was 9 years ago I started asking for error reporting. And the explanation why I have been asking for the error reporting is because my customers are mainly ISPs and also enterprise networks. And they sometimes get a wrong or bad deployment or whatever bad situation with IPv6, and Happy Ables was hiding that. Okay, so we really need, and I was not realizing that also this is useful for developers because I am in a different type of business. But we really need that when an enterprise network or an ISP is getting some troubles with IPv6, they get some kind of reporting. So that was the reason. Now, what I am missing is in the working group a discussion about which persona is the most important one in case we cannot achieve several of them, and how we do the reporting to these different personas. Okay, so that's the thing. I believe that if we don't have in the mailing list, because here we don't have time, a serious discussion about how we proceed, we will end up with additional 9 years discussing about the same. So please go to the list and let's have a discussion on this.
Yeah.
And
Okay.
also, probably it's not the question what's the most important persona, but which personas we can serve easily and which ones we might not be able to serve due to security and privacy considerations.
Yeah. Yeah, you finally mentioned the P word there. Yes. Okay, right. So we've got like 5 minutes left. So Xupeng, if you can highlight your work, so at least the working group in the room is aware of it and can go and look at it, and then we'll have a wrap up. So over to you, a quick one.
So I recently published a draft in V6.org. It's called Enhanced Dual Stack. It aims to accelerate the enterprise IPv6 adoption. Because without it, I'm concerned that maybe a decade from now, still many enterprises, especially small and medium enterprises, still, on IPv4. So what is this enhanced dual stack? Why we need it? In short, I feel that the current dual stack doesn't work well enough. Supposedly, when you deploy dual stack, the ideal way should be that, if IPv6 works, then it's used. If IPv6 doesn't work, then IPv4 is used. And therefore, for the person who deploy dual stack, there should be no, disturbance of user experience. And if this is the case, then it will be very easy for enterprise to decide to deploy dual stack, because you deploy it will not affect user experience. And if there are IPv6 problem, I will figure out, for example, with this reporting mechanism that we are talking about, fix the IPv6 problem over time. So the aim is trying to make IPv6 very easy to start. Fix the problem over time. But this is not the case. Why? Because today, a dual stack host, when you try to decide whether to use IPv6 or IPv4, it basically, use the RFC 6724 rules. And sometimes the rules may select IPv6 even when IPv6 is broken. As a result, because it can be broken, then, before the deployer switch on IPv6, he must do a lot of validation work to make sure that, everything is tracked and, it's going to work. And then face the judgment moment when he switch IPv6 on. So I think that, this problem
1 minute.
is severe, because then it's too much work and too risky. And this is why users are not deploying it. And this is also why we believe that if, enhance dual stack is to get, dual stack to where it should be is like, if IPv6 work, then use it. Otherwise, use IPv4. So how do we do this? Basically, we need 3 enhancements. The first one is OS implementation profile. Happy Eyeball already, move the traditional DO stack 1 big step towards enhanced DO stack. We just need to have an OS implementation profile so that the most number of applications can benefit from it. Otherwise, if Happy Eyeball is implemented by an application, then other applications may not benefit from it. The second enhancement is the traditional application who continue to use, get address info or connect, etc. They also need to be enhanced to take performance into consideration. Currently, RFC 6724 say that you can consider performance. We want to change it to you should consider performance and also specify, how you take performance into consideration. And the last one is the reporting mechanism that we talk about. I think that Mia talked about, Philip talked about. If IPv6 is not selected, why? So that, we can try to identify and fix problem. So this is the last slide. The key point is that we need an OS implementation profile from the Happy Working Group to benefit the most number of applications. And also we need some supporting, error reporting if IPv6 is not used. With this, I want to, invite people to read the draft and provide your comment. Because we are from the operation background, we really hope, developer can get involved and help, do this to accelerate enterprise adoption.
Okay.
Thank you.
Thank you very much. So Eric and I just need a couple of minutes just to wrap up. So we'll do that now. Eric, do you want to say something first? Or? Okay, so yeah, thank you everyone for the contributions. It's been almost as incident-packed as the third place playoff match, the England 6, France 4. I feel like I'm being blown away by everything. I think it's been really great to finally get some, it looks like we're heading to consensus on the main draft. I think what we need to do is have more discussions through the week. Eric and I are just the referees of this match, if you like. It's up to you guys, implementers, people writing the draft to get together and talk to each other and head towards that consensus. And hopefully over the next 2 or 3 weeks, that consensus can be reflected into the draft, the rest of the V6 part, for example, and the implementers. I think what would be interesting from our point of view is to understand, as I said, Max made it quite clear in one of his slides what the deviations from the spec were. It'd be interesting to see from the other implementers something similar to that and look at what the common differences are. Are they just the default values that maybe need tweaking in the draft? Are there other things to get some consensus on that as well? And the reporting topic, clearly we need to take that forward as well. I think the last thing I'd say is procedurally in the charter, we're supposed to finish this work by the end of July, which isn't going to happen. The ADs, though, have said they're very happy for us to just kick that down the road a bit. I think the important thing is we've got some great implementations moving forward. We've got the draft in a really good shape. So if people can just put a little bit of effort in over the next 2 or 3 weeks to get that almost over the line, and we can then consider a working group last call, which obviously then gets other eyes to come in and look at it as well. So thank you very much. Eric, do you want to add anything?
Thank you, and thank you, Brian, as you had to stroll away for taking notes.
Oh, yes, thank you. Great. So with that, we're done. Thank you very much, everyone. Indeed. I'm not quite sure what went wrong with the clicker. I'm pretty sure the light was on.
The light was on and